Hello, and welcome back to yet another retro channel. Today, we're going to take a look at yet another PLA replacement. This one may have been around for a while, but it was one that I had never heard of until I was sifting through the retro stuffs section of PCBWay's shared projects page. And I ran across this little board, PLA adapter TL866. What this is an adapter to use an EPROM in place of a PLA. Now, you might think that sounds a little silly until you think about it. What you have in a PLA is a 28-pin chip. 24 of those pins consist of 8 outputs and 16 inputs. The other 4 pins are VCC 5 volts, ground, a chip enable or output enable pin, and 1 pin that's not connected. Pin 1 on the PLA has no connection. An EPROM has 16 address pins, which are essentially just inputs, and 8 output pins, which show the memory at the byte at each of 64,000 memory locations, 65,536. So you have a 16 input and 8 output device with VCC, 5 volts, ground, a chip enable or OE/VPP where the programming voltage would go, and there's another pin, I forget what that is, but essentially they're largely the same thing. The only caveat is the PLA has tighter timings than your typical EPROM. The timings, as I understand it, need to be 45 nanoseconds or below response time. So when the input changes, there has to be 45 nanoseconds or less delay between that and the output coming good. So someone has gone to the trouble of making this little board which shifts around a few pins. The pinouts are not exactly the same, obviously, between an EPROM and a PLA, but this board shifts a few pins around, and this board can actually be used either to plug your PLA in and use this board to read that PLA out in your EPROM programmer. A simple TL866 Mini Pro programmer will do the job. Or you can use it to put the EPROM into and plug that into the PLA slot on your C64, and it will act as a PLA. On the back here, if you can look closely, there are two solder pads that you simply put a blob of solder onto jumper to make it a PLA replacement. If you leave those off, then it's configured for reading a PLA. This solution is quite economical. The little boards, you all know how PCBWay works. You can get 5 or 10 small boards for $5 plus shipping and tax. It takes you about a week and a half to 2 weeks to get them, and you know, that's a really relatively low expense. If you get 10 of them for $5, then you're getting them for 50 cents a piece plus whatever the shipping and tax is. So you're probably still talking less than $2 per board. The EPROMs that I'm actually using EEPROMs. These are electrically erasable, programmable read-only memories. These particular ones are WinBond. They're W27C512-45Z, meaning the -45 at the end means that these are 45 nanosecond chips. So they should meet the timings required by the PLA, by the C64 for the PLA. These I got for less than $2 a piece. I found them on both eBay and AliExpress. These particular ones that I'm using now are the ones from eBay. The ones from AliExpress haven't arrived yet, but in either case, we're talking, less than $2 a chip. So $2 a chip, $2 for the board, and the support being pin headers and a dip socket. So we're talking probably under $5 for this entire PLA replacement. If it works, it's a very economical solution. I know the GAL PLAs are out there that are also a very economical solution. The one issue I think with those that's going to be important going forward is that the GALs, those 20V8 GALs that are used in it, those are no longer in production, and eventually they'll get scarce, and finally the prices will start going up, and then they'll be next to impossible to find, like a lot of other chips are these days. Whereas this particular chip here, this WinBond, this was manufactured, if I'm reading this right, in the 21st week of 2022. These are still being manufactured today. So these should be around for a good long time. If this solution works, if this solution is reliable and viable, it could be a much longer term solution to the inexpensive PLA replacement. Now, obviously, there are other PLA replacements out there, the Plankton, PL Advanced, a few others. Most of those are relying on FPGAs or CPLDs. And as we've seen in recent times, in the last three and a half years, when there's a scarcity of those chips, or when there are issues with delivery or whatever, the prices for those go through the roof. So you're not going to get cheap PLA replacements out of CPLDs and FPGAs. I think this is a good solution. So we're going to examine it today. We're going to put one together. We are going to pop it into my test C64 and see how it performs. And then at the end, we'll take a look at it on the logic analyzer to make sure the timings are good. So let's get started by putting this together. Now, there isn't a lot in the shared projects page on PCBWay as to instructions how to put this together. So there are a couple of confusing things that I need to note for you. If you take a close look, these two vias at the bottom here have the square the square solder pads. Those usually indicate pin 1. That's a mistake on this board. Those are not pin 1. Pin 1 are here. You can remember that by these two little silkscreen marks. Those are what pass for the notch on this PCB. So this is the top. This is pin 1. Ignore the square solder pads down here. And the second thing you need to note is that the pin headers for plugging into the PLA slot socket on the motherboard go in the left-hand set of vias. And then the socket for the EPROM will go in the right-hand set of vias. And again, as I said, this is the front side of the board, this is the bottom side of the board, and the bottom side of the board is where the little solder pads are that you need to bridge to make this PLA replacement. So, all that being said, let me go ahead and solder this up. Now, let me take care of that solder pad first. A little blob of solder. And close inspection shows that well bridged. So, put the pin headers and then use a breadboard to hold them straight while I solder them. One little caveat when doing this, these vias are very close together with the ones next to them, so it's very easy to accidentally touch them and drop some solder into a via you're not ready to solder yet, and that'll make it difficult or impossible to get the socket into those vias. So I just go back and clean this up with a little braid, and okay, now the socket. Little inspection for solder bridges. Oh, looks like we're good to go. All right. Next step will be to program our EEPROM. Now, I have already downloaded the file from a fellow's website that seems to have originally put this together. I will link that in the comments below, as well as the shared projects page on PCBWay, so that you can take a look at that. I'll also be linking to a fellow YouTuber who goes by Captain Commodore. He's been looking at the GAL PLA and some issues that he's been having with it, where he does talk about the timing to some degree. So if you want further information on how the PLA operates and what its requirements are, you can take a look at that video. For the meantime, okay, so we'll pop the EEPROM into our Mini Pro programmer, make sure it's seated well. Sorry, the camera is this particular camera on the desk here pointed at the Mini Pro is not the best at autofocus. So we are now going to, we've already selected the WinBond W27C512 DIP28 package, and then we will load the binary file, 64K binary file. Do a blank check on the ROM. Whoop, not blank. So we will erase it. Okay. Blank check it again. Oh, blank check it again. This time it's reading blank. And program it. Okay. So now we have a programmed EEPROM to replace the PLA. Okay. For your own sanity, if you don't have one of these little chip leg formers, get one. They will easily make up for the couple dollars they cost in, and like I said, saving your sanity trying to get chips mounted. You just pop the chip in there, wide chips on this side, narrow chips on this side, give it a squeeze, and off you go. So now this should fit right into the socket without any difficulty. There she goes. No bent pins, everything in. That should be a PLA replacement now. So let me grab my ZIF board. As you can see, I forgot to put the PLA back in the last time. Okay, so let's go ahead and put this into the ZIF board. I'll lock it in place and give it a shot. Well, will you look at that? It works. So this is at least looking to be a viable solution. We have basic, we have the cursor, so it's talking to memory, it's talking to the I/O chips, it's talking to the ROMs, all successfully. So let's go ahead and hook up the diagnostics harness and see what that has to tell us. Okay, diagnostics are installed and ready to run. Good, they're running. Give this a few minutes to run through and we'll see what results we get. All right, diagnostics pass 100%. Next thing to do is load a game. So diagnostics harness out. Et voila. Easy flash cartridge in. And we're going to need a keyboard. And a joystick. Okay. And it works with Easy Flash. Try Super Zaxxon. We know that one's a challenge. Not seeing the graphical corruption. We're seeing my very poor playing skills. Okay, and I believe the game that Captain Commodore was having trouble with was Ghostbusters, so let's take a look at that. What's the other joystick? Wish the game makers would have made up their mind which they consider to be joystick 1 and which they consider to be joystick 2. I don't know, seems to be working. I don't know, seems to be working to me. So, there you go, there you have it. A new PLA solution, or not a new one. I think this has been around for quite a while. It just, for some reason, didn't get widely publicized. My guess is because it was probably hard to find EPROMs with the right timing. If you get the ones with the right timing, it seems to work very well. Okay, and now here is a look at the logic analyzer hooked up to the CAS and CAS-RAM signals. CAS is the input to the PLA, and CAS-RAM is the output going to the RAM. This is going to give us a good picture of the timing. As I said, the timing specifications for the PLA, as I understand it, I could be wrong here, feel free to correct me in the comments if I am, but require the delay between the falling edge of the input signal and the falling edge of the output signal should be no more than 45 nanoseconds. And if you look closely here, you will see that the falling edge happens at plus 90. So we have 10, 20, 21 or 22 nanoseconds between the falling edge of the input and the falling edge of the output. So that seems to be good. And if we take multiple samples, we're always getting within the same range when there's a signal. Sorry, sometimes it doesn't happen. I'm not sure exactly how CAS and CAS-RAM relate to each other, but when there is a falling edge here and a falling edge here, they are no more than 20 to 22 nanoseconds apart. So we are good on timing. All right. And again, a pretty cheap solution. I think I put this together, each one for about $5 US. And it's quick, it's easy. I mean, anyone can do it. There's nothing complex about it. You just need the programmer or to know someone who has a EPROM programmer, and you're ready to go. So, thank you for watching. I hope you appreciated maybe a little better quality video this time around. I picked up an inexpensive webcam to use instead of the cheap USB camera that I had before. So I think we've got a little better quality on this video. I appreciate you watching. I appreciate those of you who watched the previous videos and subscribe to the channel. If you enjoyed this video, please give it a like. That helps me out. If you didn't, you know what to do there too. No problem. But if you would like to see more content like this, go ahead and subscribe to the channel and ring the little notification bell so you get notified when I release new content. And that'll do it. Everybody have a great day, great week. Be happy, be safe, and we'll talk to you next time.